you can achieve around 15% power savings instantly in the air handling units of your HVAC systems in your IT building or commercial buildings. How this can be achieved, let us see in depth. How to save the energy instantly in your AHU blowers and in the buildings. Your AHU blowers are basically designed for peak summer conditions and sized accordingly. In most of the energy audits we have conducted during the buildings and in the industries, we find the blowers are partly loaded around 50% only, especially on the air handling blowers. These AHUs are fitted with VFD and operated with manual hertz settings in some of the IT buildings and commercial buildings, and many of the IT buildings have already switched over to BMS. They have incorporated this all the HVAC systems in the BMS software. During the peak season and in the daytime, you are running your blower at 45 to 50 Hz of at VHD. In the night and other seasons, you run at 35 to 40 Hz, less setting only, Hertz setting only. So you can achieve the power savings of around 30%. You are achieving already during the night and in the off seasons. So when the blower is partly loaded around 50%, you can still achieve another 15% instantly by achieving this redesigning of the motor and blower pulleys and choosing an energy efficient cogged belts between the motor and blower pulleys. This is a very low cost and the payback is in very few months. Thanks to the Bureau of Energy Efficiency, the refresher guide to the energy manager and auditors. You can see the curve, the graph, the percentage speed versus the percentage power and torque on any variable torque load. Maybe it is a centrifugal blower or an axial flow fan or a centrifugal pump in the utilities. These are all the variable torque loads, and these loads, like especially the blowers and fans, they need much lower torque at lower speeds than at high speeds. This is the focus area which you are trying to achieve the energy savings now. Elaborating more on the variable torque loads, the VFD is used for the variable, mandatorily the VFD needs to be used for a variable torque load for a blower or fan especially. The VFDs used in the blower and fan can optimize the torque between the motor and the load and as well facilitate the blower to run at an efficient band of its FPS, fan performance curve. The image sourced from LinkedIn, and it clearly shows that at 100% of the load, you can see the torque is 100% and the speed is also 100%. Whereas at the 50% of the load, the blower, you can see the torque is only 25% of the full load torque and the HP is only 12.5% of the full load brake horsepower of the blower. This graph indicates clearly the gap between the supply and the demanded torque from the motor to the blower. Basically, the blower is a variable torque load which we are trying to utilize here. This is the area which is not focused at all till now, and it is high time that we have to focus this area and achieve the energy savings instantly and affordably. Thousands of case studies have been done in this region, and with cogged belts and VFD and redesigned pulleys and belts to exercise the proof of achieving this energy savings and reducing the torque gap between the supply and demand torque from the motor to blower. Coming to the case study of this, you can see it's an automobile major based at Chennai, and it is done in an air handling unit in the year 2024 by our MSB team. It's a 7.5 kilowatt motor, VFD operated. You can see the before study, before replacing the belts and pulleys, at 50 Hz you can see the blower RPM is at 80 RPM and the energy consumption is almost 5 kilowatt, and after redesigning the belts and pulleys, and you can see the motor is operated at 43 Hz, but the blower RPM is maintained at 880. See, the conservation means for the given output, what is the input reduction that is possible? This is what it is achieved here. For the same blower output RPM, 880 RPM, the input reduction has happened from 5 to 4.2, almost 16% savings is achieved here. When many of your blowers are costing more than lakhs of rupees, please spend a few thousands more to replace the rubberized V-belts with energy efficient polymerized cogged belts. These cogged belts by design is having 30% more power carrying capacity, and it has a better grip and high coefficient of friction, and it always keeps the slippage less than 2%, steady slippage of less than 2%, and its life is double that of a V-belt life, utility life, useful life, and it improves the drive efficiency with less power consumption. You can see the images how the V-belts so heavy and so oversized on a AHU blower, and how the cogged belt is performing very clearly on a matched pulley as such. This case study done on a IT building in Bangalore, almost 7.5 kilowatt. We have taken during the case study, the study was taken, the VFD is kept on manual and the frequency is kept at 45 Hertz, and the fan RPM is maintained at 780 RPM. And you can see the before the study and after the changing of redesigned pulleys and belts, the VFD frequency was kept at 42 Hertz only, and the same blower RPM is maintained. The output is maintained the same blower RPM around 780, but you can see the input kilowatt has dropped from 7.27 to 6.06, almost 16% savings is achieved in this Bangalore based branded blower. It is an AHU blower branded in the IT building here. This is also done by the MSB team as such. So overall, if you see a 2-inch reduction in motor pulley, you can see a 8-inch motor pulley driving a 10-inch fan pulley at 1470 RPM motor, and the fan RPM is around 1180 RPM. It was taking almost 26 kilowatt on a 50 HP motor, blower motor. And when the motor the pulley was resized to a 6-inch from 8-inch to 6-inch, you can see the 1470 RPM, it was driving the blower at 880 RPM only, and the drop in kilowatt is almost 11 kilowatt. This is to reinstate the fan affinity loss, how this is utilized, and the belts and pulleys plays a critical part to reduce the intermediate power transmission from the motor to blower. Also, the pulleys need to be replaced once in 40,000 years of usage. Many industries and buildings we find more than decades of working, these pulleys are there, but this needs to be replaced for every 40,000 hours, that is almost around 5 years of usage. Visible sign in a pulley is glossy looking and dished out pulleys. This needs to be removed immediately and replaced with a correct matched precision engineered pulley as such. Coming to the next case study, this is done on a Danfoss VFD major, international major based at Chennai. It is again on a air handling unit. You can see it is done on the year 2024 by our MSB team only, and you can see it is a 18.5 kilowatt 25 HP blower, AHU blower, and we should appreciate the VFD major Danfoss. They have done two types of study. At 50 Hertz what is the savings, and at 33 Hertz what is the savings. They have studied the day and night time usage and found they maintained the blower RPM at 860 RPM and during the daytime, and at the same 50 Hertz the blower was consuming almost 14.5 kilowatt with V belts. With the cogged belts it was consuming only 12.9. So around 11% was achieved from the change from V belts to cogged belts, and redesigning of the pulleys for the VFD application from 33 Hertz to 30 Hertz, the Hertz frequency was changed, but the blower RPM was maintained at 550 RPM only, and here it is almost 22% achieved. So you can see the energy savings possible instantly by redesigning of the pulleys and belts. Thanks to the all the case studies, these case studies have been published in this energy monitoring and conservation practices in commercial buildings, and the another book is Conserve Energy Through and Restore Productivity in Machines Through Belts and Pulley Drives. These books are available in Notion Press, and you can kindly give your valuable feedback here. Thank you, thank you, thank you.